This video is going to teach you how to factor a trinomial where the leading coefficient is not 1. So there's going to be a number in front of the x squared on these problems. So these are the steps to follow if the leading coefficient is not 1. So this number here in the front is not 1. So every day when we factor, every time we factor, we see the F word here. The very first step is always to see if there's a GCF, something that divides into all the terms or something they have in common. So with problem 15, the first step we're going to skip because there is no GCF that is greater than 1. So 1 goes into everything, so we don't need it. When we say there is no GCF, that means greater than 1. If you fail to do this, you will not get the right answer in the end. Okay. The next step, you're going to take the A value, so this number here in the front, and you're going to put the 5 and the x in the front spot of your parentheses like this. Okay. Now, clearly something's wrong because 5x times 5x doesn't get you back this. So remember, when you FOIL, your goal is to multiply everything together and get this back. So we're going to fix that in a moment, so bear with me. So that was step 2. Step 3 is you're going to think of two numbers that multiply to give you AC. So you're going to take A, so this is A, this is B, and this is C. So you're going to take A and C and multiply them together. So 5 times 4 is 20. So you need to think of, so step 3, you have to think of what multiplies to 20. And then it has to add to the B value. So we have to think of what multiplies to 20, and it has to add to 21, this number here. So feel free to pause the video and give yourself time, because every single person takes different time in coming up with those two numbers. Some people are going to be quick, some people take longer. So I always list all the factors: 1 times 20, 2 times 10, 4 times 5, and it has to add to a positive number. So I know the bigger number in the pair is positive. And because it has to multiply to a positive, I know they're both positive, because a positive times a positive is a positive. And we see that 1 and 20 would add to 21. So that's how we know which pair of numbers to pick. So that was step 3. Now step 4 is you're going to put those numbers here and here. So it doesn't matter which one goes first. So I'm going to put positive 1, and then I'm going to put positive 20. So that was step 4. Insert these numbers into the parenthesis here and here. Then now this is the really weird step. The very last step is to take the numbers that are paired together in the parentheses and simplify them as if they were fractions. So what I mean by that is if you had a 5 and a 1 in a fraction, nothing divides both of these. So it's going to stay 5x plus 1. Now over here, if you had 5/20ths, like if this was a fraction, so if I had 5/20ths, 5/20ths would simplify to 1 and a 4. So this is going to become, so in other words, 5 goes into both of these once, so you're just going to have 1x, and then 20 divided by 5 is 4. Now, the reason why we ended up having to divide out this 5 right here is because, remember, if we go back to the original problem, we took this 5x and we put it in the front and we put 5 times too much. So remember, when we FOIL here, 5x times 5x would not get us this back. So we're essentially dividing out that extra factor of 5. So that's why this process works. Now, if you want to be committed to doing well in this class, you want to do a quick check. Before you circle this and say, okay, I'm done, what if you forgot to do this step, right? Then your answer wouldn't have been right because 5x times 5x is 25. So the whole point of this when you factor is that if I do a check step, if I multiply 5x times x, I would get 5x squared. And then if I multiply 5x times 1 or 4, that would be 20x. And then 1 times x is 1x, and 1 times 4 is 4. And then when I combine the like terms, we get what we started with. So if you're committed to being successful in this class, you're going to check them. And if you don't have time to check the whole thing, you should at least check this. Check the first. Do in your head 5x times x and make sure you get 5x squared. And then do 1 times 4 and make sure you get this number. So the first one should get you this when you multiply it, and the last one should get you that. That doesn't mean you're right. It means you feel good about your solution or your factoring. Now, there is another way to do this. For the remainder of the video, I am going to show you these steps, because the other way to do these problems, you can refer back to 6.5. So I'm going to do this problem again, and it is completely up to you which method you would like to use. So if you want to use the other method, so method 2, this is going to use the same steps, but then when you get to step 4, instead of doing this, inserting the numbers, instead what you're going to do is take out the 21x and replace it with these two numbers here. So replace it with 1x and 20x. So in other words, 1x plus 20x is 21x. So then I bring down the rest of the problem. And now I went from 3 terms to now 4 terms. And now you're going to use the steps that you learned in 6.5. So that is why I'm not going to waste my time doing all these problems this way, because you can refer to your notes that we already took on how to group. So remember, when you group, you put the first 2 together and the last 2 together. And then you ask yourself, what do these 2 terms have in common? So both of these have an x in common. So x times 5x is 5x squared, and x times 1 is 1x. Then over here, 4 goes into both of these. And then I'd have 4 times 5x is 20x, and 4 times 1 is 4. Now, if I did this correctly, these two should match if this is factorable by grouping. So when they match, you put these two together on the outside and then bring down one of these. So you can see we get the same answer here. They're just in a different order, but same thing here. So those are your 2 alternatives to factoring when you have 3 terms and there is a number larger than 1 in the front. So this is called factor by grouping. We learned this in section 6.5 in this class. All right, so let's go ahead and try another example. So the very first step is always check if there is a GCF. So is there something they all have in common? Well, for sure, they all have a y. So definitely y. And then the last number is a 0 and a 5. So I know 5 definitely goes into all these numbers. So this is going to be step 1. So 5y times 9y squared. So when we multiply these two here, you get this 45y cubed. Now 5, let's see how many times 60. Let's see how many times 5 goes into that. 12 times. So that's why I'm going to have negative 12. And if I have a y here, I need one more. These two here, when I multiply them, would make this quantity here. And then 5y times 4, these two, would multiply to get 20y. So that was step 1. That's called the GCF step. When do I do it? Always. No matter what type of factoring I'm doing, that is always step 1. Step 2, start your parentheses out. So you're going to take the a value. Now this 5y is going to get dropped down every step. So you're going to ignore this and just bring it down. Okay? So now you're going to set up your problem. We're going to have 9y and 9y. So you're going to take this and it goes in the front of the parentheses. So that was step 2. Now keep in mind there is a 5y in the front. So this just gets brought down. But I don't want to look at it. I don't want it to get confusing. So then step 3 is you're going to take A and C. So remember this is A, B, and C. You're going to take these two numbers and multiply them. So 9 times 4 is 36. So I have to think about what multiplies to 36, and it has to add to B, which is negative 12. So you can go ahead and pause the video and see if you know what numbers to use. So we always have 1 times itself, 2 times 18, 3 times 12, 4 times 9, 6 times 6. So I make a list and then I look at the number it has to add to. If it has to add to a negative number, then I know the bigger number is negative for sure. So whatever this is tells you the bigger number is the one that has the negative. But it has to multiply to a positive 36, so a negative times a negative is a positive. So now I'm going to add all of these and find out which one would get me negative 12. So if I pick the first one, if I do negative 1 plus negative 36, that doesn't work. Negative 2 plus negative 18. That doesn't work. Negative 3 plus negative 12. That doesn't work. Negative 4 plus negative 9. That doesn't work. And negative 6 plus negative 6, that works. It gets me the negative 12. So again, they multiply. So if I change it to a multiplication, they multiply to 36. Whoops. Negative 6 times negative 6. They multiply to 36 and they add to negative 12. So that is the process you should go through to figure out which numbers to choose. So now the next step is I'm going to put the negative 6 into the little spots in your parentheses here. And then finally, the last step is what divides both the numbers paired in the parentheses. So 3 can go into both of these. So then it's going to become 3y minus 2. And then the same thing here, 3 can go into both of these, and we would get 3y minus 2. And then that would be our final answer. Now, the reason why we're not putting this 3 in the front is because it wasn't the GCF of the entire problem. That's when it goes in the front, when it's the GCF for the entire problem. So this is just going to get divided out because I put an extra factor of 9. 9 times 9 is 81. So when you FOIL this, you don't get this 9y squared. So when you divide out a 3 and divide out another 3, that's essentially like dividing out that extra 9 that I put into the problem. So that's why this works. Now, again, if I'm dedicated to success, I want to make sure that I have my answer correctly because I could have messed up and made an error when I was doing this. So I want to show you how to check. So if I want to check, I have 3 things to multiply. Pick 2 of them at a time. So I'm going to go ahead and multiply these 2 here. So 5y times 3y is 15y squared. 5y times negative 2 is negative 10y. Then I'm going to take that and bring down this next one here. So again, I could have done these 2 together first. It really doesn't matter. You get the same answer in the end. So then we have 5y squared times 3y. That is 45y cubed. And then 15y squared times negative 2. That's negative 30y squared. Negative 10y times 3y. That's negative 30y squared. And then negative 10y times negative 2 is positive 20y. And then we can combine the like terms and get negative 60y squared. And you can see that the answer here is correct because the answer we get when we check it is exactly what we started with. So 40y cubed minus 60y squared plus 20y. So this is how you check it. You take the answer you get and multiply it out to see if you get what you started with. All right, let's go ahead and continue and try another problem here. So the very first step is to see if there is a GCF, something that goes into all of them. So for this one, we are going to skip. There is no GCF greater than 1. Then step 2 is you're going to take the 7 and the x, and you're going to put it here, and you're going to put it here. Okay. Then you're going to make the rainbow, and you're going to multiply A and C. So 7 times negative 6. That's negative 42. So step 3, I have to think about what multiplies to negative 42, and it has to add to negative 11. So go ahead and pause the video and see if you can find those 2 numbers. All right, so let's check in here. So 1 times 42, it's even, so 2 times 21. If I add 4 plus 2, that's 6, so I know, because when I add the 2 digits, it's 6. I know that 3 can go into it. So 3 times 14. 4 doesn't go into it. 5 doesn't because it doesn't end in a 0 and 5. 6 does since 2 and 3 are on the list. That's how I know that 6 goes into 42. Okay, so we have a pretty good list here. Now, has to add to a negative. So since it has to add to a negative, I know the bigger number is negative. And since it has to multiply to a negative, one has to be positive and one has to be negative. So that's how I figure out where the negative goes. Now I'm going to add these and find which one would make negative 11. So if I take 3 and I add negative 14 together, I would get the negative 11. And when I multiply them, I get negative 42. So that's how I know what numbers to put here. And it doesn't matter if the 3 goes here, but the negative has to be with the 14. Okay, and then the very last step is you're going to see if there is anything that divides into the pair. So see if anything divides into 7 and 3 other than 1. Nope, so it stays the same. And then 7 goes into both of these. So we get x minus 2 here. Now again, if you're devoted to success, you want to do well in this class, not get it all wrong because you made a little mistake. At bare minimum, if you don't want to do the whole check like I showed you in the previous 2 examples, at least do this real quick in your head. 7x times x, this is what should be done in your head, 7x squared, and then you could be like, cool, got that. And then do the last two. 3 times negative 2 is negative 6, and that's what we have here. So again, this is not how to check to make sure you're 100% correct, but it's a good way to make sure that the first one and the last one, at least those two, are correct in a really quick, fast way. Alrighty, let's go ahead and check out this next problem here. So the very first step is to see if there is a GCF, if there is a number that goes into all of these. So first of all, I know that if I add 1 plus 2, it's 3. So I know 3 goes into 12. I know 3 goes into 60. And I know 3 goes into 75. So it definitely has a GCF of 3. So that's going to go in the front. Then 3 times 4. So 3 times 4 gets the 12. So then x squared. And then 3 times negative 20x. 3 times negative 20x is negative 60x. And then 3 times positive 25. 3 times 25 is 75. So that is the very first step, is the GCF. Now, if this is my answer blank, that 3 is not going anywhere. I need that 3. Then the next thing I'm going to do is multiply A and C. So I'm going to multiply 4 times 25, and we get 100. So we have to think about what multiplies to 100, and it has to add to B. So it has to add to negative 20. Now, I would recommend that you pause the video and try to figure out what two numbers would work. So we have 1 times 100, 2 times 50, 4 times 25, 5 times 20, 10 times 10, and then it has to add to a negative, so the bigger number has to be negative. So that's how I know that 100 is negative, 50 is a negative. No, those are negative. But it has to multiply to a positive. So a negative times a negative is a positive. So that's how I know both of them needs to be negative. Okay, so now I need to figure out which ones will add to negative 20. So negative 10 plus negative 10 would add to negative 20, and they would multiply to 100. So that's how I know to pick these two. So I'm going to write 4x, whatever this is, 4x and 4x. So remember, this 3 just gets brought down every step of the way. And then you're going to take the two numbers that you found and you're going to stick them right here in the parentheses. And then the very final last step is what can divide both of these numbers here. So 2 can go into both of these. So 4 divided by 2 is 2. Negative 10 divided by 2 is negative 5. And then the same thing goes here. 2x minus 5. Now you can write your answer like that, or you can write your answer as 3 times 2x minus 5 with the little exponent, because the exponent means there's 2 of them being multiplied. So either of these would be correct. So again, if you want to be successful in this class and help yourself catch mistakes, at minimum, you want to multiply this one and this one. So 2x times 2x is 4x squared times this 3. So you want to multiply this 3 to the 2 and times this 2. So you want to multiply the first ones together and check that you get this number here. Then I'm going to take the 3 and multiply it to the last numbers in the parentheses. So 3 times -5 times the -5, and check to see if you get this number here. So you always want to check the first and the last ones at bare minimum to make sure that your answer is possible. So again, you always want to multiply the first two together to check the first number and the last two together to check the last number. When there's a GCF in the front, you just have to multiply it to the first two numbers and the last two numbers to check them.